Now, just basic projectiles, let's have a quick revision of the various equations that we learned in our previous module. So remember, this is a basic shape of our projectile motion, and that was our velocity, and this was the angle of the projection there. Remember how we said with acceleration for the horizontal, it was 0 because the velocity stayed the same. It never got faster or slower. And we worked out that the velocity of our horizontal was v cos theta. And we just integrated that to get the horizontal displacement as vt cos theta. Now, when we talked about the vertical acceleration was going to be affected by gravity because that gravity was that negative force dragging it down. So that's why we have this negative gravity there as acceleration. And we integrated that to get this, our velocity for our vertical, and then you integrate that again to get the displacement for the vertical. So this was our basic projectile equations. And now I'm going to take you through a very much exam style question where there's multiple parts in it. So in question 1, we have this particle which is projected at an angle of 45 degrees and a velocity of 60. And we're going to say the gravity is 10 meters per second squared. Starting off with question 1a, I want you to find the equation for the particle for the horizontal displacement. All right, so remember displacement was x. Now remember how we had this over here, how we said that with displacement, we could essentially make it into a right-angled triangle for that. Okay, so we'll come back to that in a little while. The first thing is, always start this off with acceleration. Really easy, acceleration, velocity, then displacement. Horizontal, we said that this is steady. So acceleration equal to 0. The velocity, remember, the horizontal velocity equals to velocity cos theta. And that's because this is when we look at our right angled triangle. So we can say that this cos theta equals to adjacent on hypotenuse. And then we just multiply the v across to get that. And now we just substitute it in. 60 for v, cos 45 degrees. Now we know that cos 45 degrees is 1 on square root 2. And that gives you 30 square root 2. And how that works is you get 60 square root 2 and we multiply it by square root 2 on square root 2, like that. And that gives us 60 square root 2 on 2, which cancels to 30 square root 2. So essentially we just rationalize the denominator there. That means this is our horizontal velocity, and then we need to integrate that to get our displacement. And remember, always in terms of dt. Integrating that, you get 30 square root 2t plus c. And we need to work out what c is. We look back to our diagram and we think to ourselves, when t equals to 0, what does x equal to? Starting from the origin, x equals to 0. Substituting in 0 there and 0 there. You get 0 equals 0 plus c. So c equals to 0. So that means our horizontal displacement is just going to be 30 square root 2t. So that was just a revision of that. Remember, starting off with acceleration, and then we think about this triangle, this right-angled triangle there, where we worked out that the initial velocity is given to us by v cos theta. And remember how I said because it's steady there, the velocity is steady, that's why we can use the initial velocity as a velocity for all of it. Let's move on to B now. So here, we just want to find the initial displacement of the vertical motion, okay? Not the equation, but just the initial displacement. Looking at the right angle triangle again. So remember how this was sine theta, where we had opposite on hypotenuse? So that was that your vertical velocity equal to v sine theta. So we just substituted in. V is 60, degrees is 45. That is 1 on square root 2 as well. So that becomes 30 square root 2. So this is just our initial displacement. So just at the very start. But we need that for C when we want to find the equation for the vertical displacement. Initially, t equals to 0, and when t equals to 0, our displacement is 0, but our velocity was 30 square root 2, which we just worked out, our initial velocity there. So starting off, acceleration, -10. Our velocity is the integration of that. So that equals to negative 10 t plus c, our constant. And now we know that when t equals to 0, our velocity equals to 30 square root 2. So that's what we substitute in here. T equals to 0 and our velocity equals to 30 square root 2. So that equals to 0, which means that c must equal to 30 square root 2 as well. So our vertical velocity is actually that. And then we just need to integrate again. Yep, so integrate that whole thing. So you get negative 10t squared on 2. So 10 and 2 cancel, give you negative 5t squared. And you just get 30 square root 2t plus d. And now we substitute in this values. So t equals to 0 and y equals to 0. So substituting that in, 0 plus 0, so that's all 0, okay? And y here equals to 0 as well. So that means that d has to equal 0. So d equals to 0 there. So that means if that equals to 0, that this must be our vertical displacement equation there. Just remember, vertical displacement is different because it's affected by that negative gravity. So we start off with the acceleration at negative 10, and then you just integrate and substitute in t equals 0 and what the initial velocity is, and you just keep going. So it's pretty much the same process as your horizontal displacement, but you're just starting off with negative 10 there. But the idea is the same. Integrate, integrate, and then you get your answer there. That's your vertical displacement equation. Now we've worked out our horizontal displacement equation and vertical displacement equation. We want to find the time taken to reach the ground. So time taken to reach the ground here. And remember, to reach the ground, what was your vertical displacement? It has to be 0. So to reach the ground means that your vertical displacement equals to 0 there. So we just literally take our vertical displacement equation here and make it equal to 0. Yeah, couldn't be simpler. And now factorize. So in this case, I can take 5t out of both of those. So that's what I've done here, which means that either this equals to 0, so 5t equals to 0, which just simplifies to t equals to 0, or this bracket here, negative t plus 6 square root 2 equals to 0. Now, remember how we said that t equals to 0, this represented our origin, which means that this must represent our time of flight. So working from that, so we just move t to that side and you find out that t equals to 6 square root 2 seconds for the time of flight, which is the same as the time taken to come back to the ground. What you need to remember for this question is when you see time of flight or time taken to reach the ground, what you need to think is that means y equals to 0. And then it's quite simple, just substitute it in, factorize and work it out. And the other thing you need to remember, you're always going to get two values, and t equals 0 represents your initial value there.